Hey everybody, Dr. A here, and in this video we're going to be exploring an example of how to compute the cross product. But before we do that, don't forget to hit like and subscribe and be on the lookout for other content like this. All right, let's get started. Compute the cross product A cross B given these two Cartesian vectors. Vector A is I, so that's 1I plus 2j plus 3k, and vector B is 4I plus 5j plus 6k. So under solution, we're going to say A cross B, and we're going to set up that 3 by 3 determinant I, j, k, and we're going to put the coefficients of these two vectors in rows 2 and 3 of this determinant. All right, just like this. And then remember, to solve a 3 by 3 determinant, we copy the first two columns off to the side, and we compute a triple product in an upwards and downwards fashion. So down here, we're going to have 6i plus 12j plus 5k. And up here, we're going to negate everything to be 15i plus 6j plus 8k. And then we are going to combine each of these expressions, right? We're going to basically add, say this bottom expression minus what's in parentheses here. And when we do that, we should end up with, what do we get when we say 6 minus 15? Negative 9i. And then we're going to have 12 minus 6 is plus 6j, and then minus 3k. And this right here is our solution of A cross B, okay? Let's do another example while we're working on this. So here we go. Here's our next example. In this next example, I want us to compute the angle theta between the vector's tails, okay? And so I'm going to give you a vector A of negative 3i minus k, and a vector B of 2i minus 3j plus k. All right, so if you remember from the from our video on cross product, we know that the magnitude of vector C equals the magnitude of vector A times the magnitude of vector B times the sine of theta. And so we can rearrange this and get theta is the arc sine of magnitude of C divided by magnitude A times magnitude B. All right, so so we can easily get magnitude A and B. There's no question about that, right? We can get magnitude A is equal to the square root of negative 3 squared plus negative 1 squared. So we'll for sure get square root of 10 here. And then the magnitude of B is square root of 2 squared plus negative 3 squared plus 1 squared. So when we punch that through, what do we get? Let's see, we get 9 plus 4 is 13, 14, so square root of 14. So we can pretty quickly check off that we have magnitude A, magnitude B. The question is, how do we get the magnitude of C? Well, first, we need to get vector C. We need to get Cartesian vector C. So to get Cartesian vector C, we are going to say that is equal to A cross B, right? And we're going to set up this determinant, this 3 by 3 determinant, I, j, k. And we're going to have negative 3, 0, negative 1, 2, negative 3, 1. Remember, those are the entries, the coefficients of those two vectors, okay? And then we're going to copy the first two rows over. So we're going to get I and J, -3, 0, 2, -3, okay? And so then we're going to perform this triple product. Pretty much the same process as we saw in the previous example. So down here, we're going to get 0i, we'll get -2j, and we'll get +9k. And then up top, we're going to get equals. We're going to negate this whole term, and we'll get a 3i -3j, and we're going to get 0k. So we'll close that off, and we're going to get Cartesian vector C equals A cross B equals, sure enough, we get -3i. We get -2j plus 3j is plus +1j. And then we're going to get 9. We're going to have 9k plus 3. No, just 9k plus 9k. There we go. I accidentally almost added a k and a j component together. That would have been a disaster. So we're going to get the magnitude of Cartesian vector C. Of course, that's -3 squared plus 1 squared plus 9 squared. So what do we get? We get 81 plus 9 is, 81 plus 1 is 82, plus 9 is 91. So square root of 91 right there. And so now we have Cartesian vector C here. So we're ready to go. We're going to say theta equals arc sine of, and it's going to be square root of 91 divided by square root of 10 times square root of 14 in that denominator. And let's see what we get. 91 square root, and then 10 square root, 14 square root, and take the arc sine of that. So I get 53.73 degrees, and that is the solution we're looking for, okay? So one other last comment on this, on just cross product operations. Remember, if you have a vector, let's say vector is B cross A, and you set that up, you have I, J, and K. The coefficients in the second row here are the coefficients of the leftmost matrix. So in a situation like this would be BX, BY, BZ, and then you'd have AX, AY, AZ here. So keep that in mind. The second row of this determinant comes from the coefficients of the left vector, and the bottom row of this determinant comes from the coefficients of the right vector, all right? Order matters.